discussed in the last class. Are you able to complete the, not a class exercise as such, but I had asked you to complete that ATM usage, right? Did you go through that and were able to complete that? Yes, Aliba.
Yes, sir. In that question, sir, will that be a right tail test or a left tail test? Because in that question, it is given that to test whether the average use of ATM user is 5 or not. Then what should we take? The hypothesis, the alternate and null hypothesis, whether it is greater than or less than? I don't know, sir.
Yes, so anyone want to answer what Aliba is asking?
Sorry, in my point of view, it will be. Sorry, in my point of view, it will be less than 5 because the bank is saying if you are using ATM card above the 5 will be charged. So it may be the less than 5. Alternative hypothesis.
Okay.
Null hypothesis equal more than 5.
Okay, so you are telling alternate hypothesis will be less than and
Less
null
than
hypothesis
five.
will
Less
be
than five.
opposite.
Yes, sir.
Alternative cannot be equal to, right? So that I have been repeating.
Okay.
Whenever you have equality sign, it can only be in the null hypothesis, right? So, but if I take your point further, you are telling that less than sign will be in the alternate and opposite of that will be in the null hypothesis. Any other answer?
Sir, is it two-tailed test?
Why do you think that it is a two-tailed test?
Two-tailed test because it's written like ATM usage in India for is 5 or not. So our alternate hypothesis will be ATM usage is equal to 5 and that null hypothesis is not equal to 5.
So which one will be null hypothesis?
Null hypothesis is not equal to 5. ATM usage monthly is not equal to 5.
Okay. Any other answer? So one of you, Ashish, is telling that it can be a left tail test, saying that because it, like, if you look into the business objective, right? Generally, bank is conducting this kind of research. That might, if they're looking into that 5 number, that means they're looking into something like maybe a penalty, maybe some additional charges beyond 5. We do not know that. So that he is assuming and he is telling that. So if that might be the business objective, we might take our alternate hypothesis is less than, that ATM is less than 5, ATM usage per month is less than 5 times. Opposite obviously greater than equal to will be null hypothesis. What Sarda is telling, we will not look into what bank is like thinking because that we do not have any information. What we have given as the research objective is whether ATM usage per monthly in India is 5. That is a spelling mistake. ATM usage is 5 or not, right? 5 times or not, right? So it is a simple case of two-tailed test because we do not know whether it is a less than or less than 5 we want to understand or greater than 5. It can be anything. So when I say something is not, x is not equal to y, that might happen that x is greater than y or x is less than y. I am not interested in that. I just want to prove that x is not equal to y, right? So find out whether, so here the issue happens when it is written like this, whether it is 5 or not, right? Because in the other cases, what I had told, the research objective, whatever is there, you take it as your alternate hypothesis. In this particular case, when it is written each, whether it is equal to something or not equal to that, right? Which one to take as alternate hypothesis, which one to take as a null hypothesis, right? But before we go ahead and say that, okay, which one of you is correct and how to proceed there, right? So why do you think that, let me answer what Ashish was telling, right? So as a researcher, you have to keep yourself separate from what is. So and that's why I told, once you have a business objective or once you have a project objective, divide that into a research objective. Because for each research objective, that is the data which you are going to get, right? Then you cannot go back, what is my business objective, what is my project objective. That is where in the first step, when you are creating your project, the linkage between project objective, what the business want to achieve, and accordingly your research objective will be formed, right? In this particular case, there is no business objective, project objective is not given, right? You are only interested in your research objective, right? We do not know. That might be a hypothetical scenario when you are using less than 5 times, there might be some additional benefit for the customer also, right? So do not assume what is your business objective and try to frame a research, your hypothesis, whatever. So that is a simple step. whatever is your research objective, change that to into a hypothesis, right? But in this particular case, like Kaliba was asking in the beginning, it is not clear, right? Whether it is greater than or less than, right? Then our answer is very simple, because when we are not sure whether we want to prove whether it is the identified data or collected data is greater than something or less than something, we are looking into the both the directions. It can be greater than something, it can be greater than that number which is being given to us, it can be less than that number. We only want to prove that, right? It can be either or. We are not interested whether it is greater than, only part of greater than, or only part of less than, right? And that is where, when you have this kind of research objective where both the options are there, right? When I say that something is not equal to ATM usage, whether it is equal to 5 or not, right? When I say it is not equal to 5, what does it mean? It can be greater than 5, it can be also less than 5, right? When I'm trying to say that yes, it is less than 5, or when it is greater than 5, then I'm looking into the direction. I'm looking to the right direction, I'm looking to the left side direction. But when there is no direction given to my test, it can be either this side, right side, or it can be either to the left side, right? So in that case, we have to take both the directions. That means it will be looking into the two-tail test, right? So when I say mean usage, let's say it is 5. So whatever number I get, it can be in the right side or it can be in the left side. As long as my objective is to prove that it is not equal to 5, right? Is this part clear? Why we are talking that as a, why we are
Yes.
thinking this as a two-tail test, or
Yes,
any
sir.
doubt? Okay.
Yes, sir.
So now what Sarada was asking, or like giving her answer, that okay, now how should I write my alternate hypothesis, null hypothesis, right? Remember that status quo, right? Status quo is always about the equality part, right? Null hypothesis, when you talk about equality sign, always will be there in your null hypothesis. So what is left out? Non-equality sign, right? So this is not equal to 5. I am going to prove that it is not equal to 5. If it is equal to 5, that is the null hypothesis. Equal to sign always will be there in your null hypothesis, whether it is a right tail, left tail, two tail, whichever hypothesis you are going to write, whether it is given or not, you have to write your. So status quo means something is equal, something remains same. So with that philosophy, what will be our alternate hypothesis?
Sir, average ATM usage is not equals to 5.
So that is what we want to prove here, right? ATM usage is not equal to 5, right? Everybody understood why we are not putting that equality sign in the alternate hypothesis, though the research objective is written whether it is 5 or not. So it is not saying prove that it is not equal to 5. It can be either case, it can be equal to or not equal to. But as per the philosophy of our hypothesis testing, right? Equal to sign always will be there in the status quo, in the null hypothesis, right? ATM usage is not equal to 5. Then ATM usage, and it is irrespective of your which kind of test. So the right tail also equal to sign will be there mandatorily. The right tail test, what I said, it is greater than 5. So in the null hypothesis will be less than equal to, right? Equal to 5, right? Now study M is, we are comparing, right? We are comparing with a given value. Given number or the expected number. That expected number is 5, right? Which are my variables?
Average ATM usage.
Average ATM usage. Okay. Dependent, independent. I hope this part is clear, because we have only one variable, right?
Not
We do not
applicable.
have any option of dependent and independent here. Data analysis method, right? So here again, one sample
Variant.
it is, but two-tailed, right? So earlier case we did a right tail test, now it will be two-tailed test, right? So now step one, everybody is clear, calculate test statistics,
Yes, sir.
right? Test statistics is nothing but your observed value, whatever you observe from your sample, that is nothing but your sample mean. 3.6 expected value, 5. Then I have to find standard error. For that, I need to find standard deviation. Standard error is equal to your standard deviation.
By square root of sample size.
What is our sample size?
15.
Square root of sample size.
15, right?
Yes, sir.
So sample size is 15. So standard error is nothing but your standard deviation. That is again sample standard deviation, right? Because it is a small data, actually we can calculate here. I hope all of you know how to calculate sample standard deviation. So whatever your mean value, right? Sorry. Subtract from each of your, so that is where you find out how distributed your points across your mean, right? What is the average value of distribution, right? So what I'm finding, for each point, how far that point is from your mean, right? That is how you calculate your variance, and you take the square root of that. That becomes your standard deviation, right? So this is the square error, which becomes the numerator of your equation. So sum of this divided by, right? So if you remember your variance formula, so what would be average distance? So variance is nothing but for each of the point, how far they are from the mean, right? Average distance or average error. Same thing which you discuss in your regression, right? Mean square error or average square error. Later in your machine learning, that will be much more required. Average variance or average square error, right? Same thing, same concept here also. Whenever we are talking about variance, how far the point lie from your mean point, right? My mean is 3.6, right? How far they lie? So that I take the distance, 5 minus 3.6, square of that, then sum it up. So that is the total sum of square errors or SSE, right? Now what happens? I divide that by the.
Can you please show again how did you get the square error? From which did you subtract it?
From each of the point. From each of the point, I subtracted mean. My mean observed value came as 3.6, right? That is nothing but my mean, average value.
Yes.
For each point, I subtracted that point.
And divided by 2, right?
No, it is not a division, right? It is a square.
It's not, I mean, square root.
Yeah, not square root. It is a square of that. I am not calculating the square root. I am calculating the square of the distance.
Yes.
So
yes.
my point is 5. My mean is 3.6. 5 minus 3.6 is how much? 1.4. Square of 1.4 is 1.96. 14 square is 14 joy is 196.
Yes, sir. Got it, sir. Thank you.
So now I take the sum of it. So this is my total square of errors, right? Sum of square of errors. If some of you have gone through regression, this is where you find sum of square error. In ANOVA also we'll discuss that. Now what happens in general formula of your variance or standard deviation, what you have found, sum of square you take, then divide by the sample size. 15 you divide, that becomes your variance. Take the square root of that, that becomes your standard deviation, right? But whenever you are calculating the sample standard deviation, we do not divide by 15, we divide by n minus 1, right? If your sample size is n, we divide by n minus 1. So rather than 15, we'll be dividing by 14, right? So that becomes your total average, right, square of errors, because this is the total sum of square of errors. I'm dividing by the sample size. Whether I'm sample size, I'm reducing by 1 because I'm calculating it for a sample, right? Then what happens? I take the square root of this because I want to calculate the standard deviation or the variance, right? If you get, this will be your value which you just got from the formula, right? So you are the lucky batch. You have chosen for online, so you can just put a formula in Excel. You can find the value. But some of you, your like classmates who have gone through the offline, so I have to like teach them the both manual and both kind of Excel version. But in a way, it is good, right? It is not always that you have to go through or you will have Excel. You should know the approach, right? Why this formula is coming 2.53, right? So if I just change the formula, right? If I just put standard deviation for population, so this, no, sorry, not this now. My actual value 2.444, right? Same thing also I could have got divided by, so in that case I would have divided by 15 rather than 14, right? So this is my sample standard deviation. This is my population standard deviation because you are calculating per our sample, right? So that's why we are using the formula where we are dividing by, if you see it is 14, I have sample size of 15, but I'm still dividing by 14, that is n minus 1, right? And that's why which you are getting in your formula. Standard deviation, this is your sample. If I put the formula standard deviation for population, you will get the same value of 2.44, right? So either you can calculate manually, whichever is easier for you. I will not look, like I said, my like aim is not to look into the calculation. My aim is to you understand the steps. You can like given a data set, you know what things need to be done. I'm only interested in that part, right? Whether you are using a formula, Excel formula or manually, I'm okay with both. But obviously for the offline student, I have to teach them both manual and Excel, right? Any questions on this? Why we are taking the why this variation is coming? So please make sure that you are using the, in case you are using the formula, you are using the formula for standard deviation as standard deviation dot s, that is my sample, right? Any questions or any doubt? So my state statistics will now become my observed value minus expected value divided by standard error, right? So again repeating, this is nothing but I'm standardizing the value, observed value or the sample mean what I've got, right? This statistics is nothing but the standardized form of your sample mean. So I got a value of minus 2.14, right? Every one of you got that number, or any question, any doubt?
Yes, sir.
Right?
Yes, sir.
Now second step is your critical value. Critical value, what will be your degrees of freedom?
14.
Correct. So degrees of freedom is still n minus 1. That is 15 minus 1, 14. Now the alpha part, right? What is alpha is given to you? Alpha is 5%, 0.05, right? So now the interesting part comes, right? Because what I'm trying to prove, I'm trying to prove whatever ATM usage, it is not equal to 5. So what do I mean by that? It can be either greater than or it can be either less than 5, right? So when I say it is not equal to 5, it can be either greater than. So 5% is what? 5% is nothing but the error which I am accepting in my research, right? So I am dividing the error also. What I am telling, when I am estimating that it is not equal to 5, I might overestimate that. I might say that it is greater than 5 half of the times. I might say that less than 5 half of the times. So my error which was originally 5%, right? That also get divided into two parts. 2.5 percentage, right? So when I go and find the critical value, I no longer look into the 5 percentage value. Understand what is happening, right? Because in the right tail test, what happens? I want to prove that something is greater than 5, right? If this was a right tail test, ATM usage is greater than 5. So my 5 percentage error will always fall into the right side of my whatever research. If I wanted to prove that it is less than 5, my error whole of 5 percentage would have fall into the left side of the distribution. But now what I'm trying to prove? I'm trying to prove it is not equal to 5. So I can be wrong also, right? Actually it is 5, but I'm proving that it is not equal to 5. So my error of saying that it is not equal to 5 can be two types. I'm telling it is greater than 5 or it is less than 5. That is where when you go and find the critical value, right? Don't look at alpha. Look at critical value at alpha by 2, right? Everybody clear why we're looking at alpha by 2? Because I'm distributing the error also. I'm saying I might be wrong, right? So error is nothing but I'm accepting that I'm wrong. I might be 5% of the times I'm wrong. In the two tail test, what I'm telling, half of the time, 2.5% of the times I might be wrong when I'm telling it is not equal to 5. In less than 5 or 2.5 percentage of the time, I might be wrong when I'm saying it is greater than 5. Both the directions. My error is also distributed in both the directions of this sampling distribution, right? So that is where we look into the alpha by 2 value, not alpha, right? Whenever we are doing a right tail or left tail test, we are looking into alpha value. When we are doing a two tail test, we are only looking into alpha by 2, right? So I'll go to the t distribution. In t distribution, do not look into 0.05, look into 0.025, right? What will be my this degrees of freedom? Degrees of freedom is 15 minus 1, 14.
14.
So what will be my value? 0.025, that is 2.5 percentage, 2.145. Because if you look into 5 percentage, it will still show 1.76, which is valid for left tail or right tail test. Remember, because we are looking into the two tail test, we are saying that our error can happen in both the directions, right? So that is where our 2.145, right? So at 14 degrees of freedom, 0.025. So alpha I'm not changing. Alpha is still 5%. What I'm saying, I'm looking into 2.5 percentage error to the right side, 2.5 percentage error to the left side, right? So 2.145, right? So now I'll go again. No need to, like I said, no need to always create, but it is always better to look into visually, right? So how much value came? 2.145. But remember, it is for both the directions. So now I'll have boundaries in both the side. 2.145 minus 2.145. This is 2.145, right? So this is my critical value, right? So this is the boundary of my critical value. Positive side 2.145, negative side value minus 2.145. Where does this value lie? Minus 2.1433.
So it is in between that two critical values.
That is somewhere very close to this number, right? 2.145. So this is my test statistics. Minus 2.1433. So what it says now, if I have got a value which is greater than 2.145, let's say 2.5, 2.2, 2.3, or I would have got a value which is less than minus 2.145, let's say minus 1.8 or minus 2 or minus 1.96, whatever is that. In both the cases, right, whatever my value, if my value was something greater than 2.145 or less than minus 2.145, then I could have rejected null hypothesis, right? Because the data which I was getting is against the null hypothesis. If I am getting a value which I am the sample data which I am getting, it's within the range of critical value, right? null hypothesis cannot be rejected because whatever information I'm getting, that is in line with my null hypothesis. That is believing that null hypothesis is true, right? In this case, I'm getting a value of minus 2.1433, right? So that is within this range, right? That is within the range of critical value. Then I cannot reject the null hypothesis, right? So that doesn't mean I'll go and say that ATM usage is equal to 5, right? Only thing what I can say that I cannot prove that it is not equal to 5. There might be a chance that it is equal to 5. So with at the end I'll write that with the information available, information I cannot reject null hypothesis. Okay. Is it clear or any doubt? Anyone having any doubt? So only important thing which you have to like kind of practice or understand in the sense that whenever we were carrying out two-tail test, our error is also getting divided in both the side. So critical value will have range in both the side. If it was a right tail test, right? So this my whatever I would have gone here and found 0.05, 14, 1.761. I would have come back and put here 1.761 in the right side. Similarly for the left side, minus 1.761, right? So only one side of the critical value because here my error can happen in both the side. My error in judgment can happen in both the side, right? So I have both the side critical value boundary, right side 2.145, mirror image left side minus 2.145. The value which I got, right, is within the range of that critical value, the boundary, right? If somewhere if I just change some numbers, right? If I just change some number is, let's say, so see it is becoming minus 2.42. So then it will become, because my mean is right now 3.33, then it will come to the left side of this boundary and then in that case I could have rejected, right? But in this particular case, the mean which I got 3.6, though it looks like less than 6, it is less than 5 by 1.4. But still I cannot go and say that for my population that it is not equal to 5. There might be a chance that population mean can be 5 when I'm getting a sample which mean is till 3.6, right? Is this part clear or any doubt? Okay. So let's jump into two sample t-test. So let me give you 2 minutes, go through it. If you still have any doubt, let us clear that out before we jump into the two sample t-test, right? Again, I'll share a slide because in online showing manual will be little difficult, but I'll try to show through slide how to do the manual calculation. So it is better to practice, right? So though it might not like because you are doing online kind of, but remember what you have to like I had mentioned, you cannot convert Excel file and put that into PDF file. Whatever result you are getting step by step, this is the test statistics I calculated. This is the critical value I found out. Then I compared and everything need to come in your white paper, right? Everything you should write in your own handwriting. Calculation part, yes. So the Excel is taking care of that. So that you need not have to worry about. Your counterparts, your colleagues, your friends, they might have to go through some difficulty. But for you, because you are giving online exams, you can do that calculation in Excel. But also I am giving you that document where step-by-step manual calculation will be given so that you know that how it is being calculated, right? How Excel is finding that same answer, right? And in case there is any doubt, you can always come back and ask me how that calculation is happening, right? So let us just jump into the two sample t-test, right? Again, because I'm telling it is a two sample t-test, that's why do not give that answer two sample t-test because like I said, I'll be much more focused how you get that answer, right? Because in your exam questions will be similar to this. I'm not going to ask you that, okay, this is a two sample t-test. Just imagine the situation when you are in the exam hall, there are for this similar kind of question, you can have 5 or 6 options. You have to go step by step. There, I won't be there, or this Excel file also will be not help, right? Because there are 8 or 10 Excel files. Once you understand that, okay, which kind of test, then calculation is easy. But unless you understand what kind of test need to be performed, what kind of hypothesis testing, all these Excel files, all these answers, all these processes will be of no use to you, right? And this is why I'm keep repeating that you have to try to form your own hypothesis at these 5 steps, right? Study M variables, dependent, independent, and what kind of test, data analysis method. That you need to be very careful about. Okay. So before we jump into this Excel part, let us try to understand what is a two sample t-test, right? So now again, and I'll say that multiple times, whatever time is left out for us. When you talk about two sample t-test, sample doesn't mean that we are collecting two samples, right? Sample here means group, right? Sample doesn't, because that part we have discussed in the beginning class itself. We are collecting sample. Most of our study will be cross-sectional. At a single time frame, we are going to collect data at a single point of time, right? So that will be totally considered. Let's say 300 data points or 500 data points or 100 data points. That is a single sample. But I can divide them into different groups. So when we talk about two sample t-test, it doesn't mean that necessarily we have collected two samples, two different samples, right? What it objectively means is when I have collected data, let's say I collected 100 data points or 200 data points, I am dividing that 200 data points into two groups to observe something, to observe some differences, or to find out whether there is some differences exist between those groups. So what can be those groups? Those groups can be certain variables related to your demographic characteristics, might be your age. I want to see certain differences, whether the amount of time people spend on internet or in OTT platform. Is there a difference in different age groups? Let's say I have two age groups, less than 30-year-old, so 18 to 30-year-old, and 30 to 60-year-old, or 30 to 45-year-old. So these are my two age groups. If I want to find out whether there is a difference exists between the number of hours they are watching, right, Netflix or whatever OTT platform they are using, so that is two groups. So that doesn't mean I went on and collected a sample of 18 to 30 separately and 30 to 45 separately. Because when I'm sending that survey, I'm sending that to all those age groups, right? I'm collecting that within 2 weeks or 1 week of time. I'm consolidating the data in a single Excel file. Then only I'm creating, okay, these people are from 18 to 30 years old. There are 60 or 70 people who are above 30 and below 45, right? So when we have two groups, sample means here there are two groups, right? Not necessarily two different samples, right? So that is first point you have to remember. Then what is the difference between independent and paired, right? So when these two groups are not related to each other, right? Like I said, let's say I want to understand whether there is a difference between this Netflix or Prime Video or your Hotstar usage between age group from 18 to 30 and above 30, below 45. These are my two age groups. 18 to 30, 30 to 45. These are my two age groups. These two groups are independent of each other. Why it is so? Because there won't be any individual either where I am collecting data, either will be into group A or group B. That person cannot be into both the groups. Both the groups are independent of each other, right? So that is the meaning of independence. Paired means for the single same respondent, I'm collecting two different data points, right? So the typical example in any study book, if you find for this two sample test, will be for a person who is going for a blood test. Most of the times, if some of your family members have gone through this sugar level test before breakfast and after breakfast, right? For the same person. So this is where the pairing of data points. So when I say paired, so paired means for the same respondent, I have two informations: the blood sugar level before breakfast and after breakfast. So that is the any statistics textbook you read, and most of the time this paired t-test is utilized in those kind of phenomena, right? Healthcare research or scientific research. Because for the same respondent, before taking medicine, what was your cholesterol level, and after taking medicine, what was the cholesterol level, right? So in that case, that becomes a paired t-test, right? Again, two groups, because when the two groups doesn't mean two different groups of respondents. one group of respondent, but for each respondent, I have two data points. So two groups of data points. So paired means two groups of data points. Independent means two groups of your respondent. Right? Is this part clear or any doubt? Anybody having any doubt on two sample t-test? First point is two sample doesn't mean we have two samples. Two sample means two groups. If we are looking into two groups of respondent that is independent, that means groups of respondent are independent of each other. When we look into pair, we are looking into two groups of data point for the same group of respondent, right? So like blood test, I have like let's say one drug company like Cipla or any company. So they are coming up with a new drug and they want to see that. Sorry, after taking the drugs, there is a difference in one person's blood sugar level. So pre-breakfast they check the blood sugar level, then that person takes the medicine. Post-breakfast they check the blood sugar level. Similarly, they take it for 10, 15 or 100 or 1000 of respondent. So pre-breakfast, after taking medicine, or let's say there is a medicine for cholesterol level, right? So before you take that medicine, what is your cholesterol level? Let's say 80, 100 or whatever, 120 or 200. Then after taking medicine, after 2 hours, what is your cholesterol level, right? So for the same respondent, you are having two data points. Like that, you will have 1000 data points. 1000 into 2 means 1000 respondent means 1000 into 2 means 2000 data points. But so for each, so that is basically 1000 pair of data points. That is not 2000 separate data points, 1000 pair of data points, because for each respondent we have two data points, right? So in those situations, we are carrying out a paired sample t-test. Definition wise, it looks simple, but when without any information, whether it is a paired and independence, some questions has been given, you will find it tricky, right? What will I suggest? In the QT also, those same questions would have been followed up without looking into what kind of answer, right? Just go through the question and try to find out whether it is a two sample independent t-test or two sample paired t-test. Right? If you're able to do that properly, then balance rest of the work, Excel will be doing the calculation. Finding which is a paired t-test, paired two sample t-test, and which is independent two sample t-test, that is the difficulty part, right? Again, you need practice, some bit of understanding, right? So, but definition wise, is it clear or any questions, any doubt?
So
Now
can we
the, yeah, what?
can you say paired as a dependent?
Here there is no dependent independent, right? So I do not have any dependent independent. It is only in the some effect is happening, something is happening. You are going through a blood test or you are taking some medicines. So what kind of medicines, what is happening? That information is not given to us. Only option what is given there are two groups of data point, right? For dependent independent to happen, you need to have some information, right? You need to have information that okay, this is dependent on the other part.
Yes, sir.
But obviously, in a other way to look into, like if I'm just imagining this scenario, why that drug research company is doing this research? Let's say Cipla or any other company. So they want to prove that by taking this medicine, right, the person's cholesterol level is decreasing or blood sugar level is within the limit, right? So in that case, if you imagine from the business objective, right? So they want to prove that the blood sugar level, decrease in blood sugar level or decrease in cholesterol level in a human's body is dependent on the intake of the drugs, right? Whatever drug is taking, right? So that is where they indirectly they're trying to prove. In a paired test, if you see, you can have that kind of understanding that okay, whenever let's say you go through certain coaching, before taking that coaching, your let's say performance in this kind of written test is something, let's say you are scoring 30 out of 50 or 35 out of 50. By taking that, you are increasing your score. So indirectly what it means, by taking that test, you have improved your whatever, like let's say score or performance, right? So that is one way of talking about that also, right? In the independent case, what happens? I have two independent group of respondents. I want to measure the emotional quotient about male and female student. I want to understand their like kind of, let's say, IQ level or their like exam performance between male student and female student. Right. So these two groups are not related to each other. These two groups have different data points. Right. And I'm trying to say that, okay, yes, based on whatever gender, based on their age group, based on their location, there will be some difference. So the difference in score each due to maybe gender, I do not know, maybe due to the location, maybe due to the whatever, like let's say whatever background they are from, income group. Let's say I take different income groups, people, different student from different income background, and I say that there will be a difference. There will be a difference in their exam performance or like let's say whatever placement they are getting or whatever other parameters I'm choosing. Right. So that is where your dependent independent will be. Independent will be your that location, background, gender. Dependent will be your whatever exam performance or whatever parameter I'm trying to test. Is this clear or any doubt?
Yes.
Now the point of whenever we have independent, we have two different groups of respondent, right? So there will be two situations. These two groups might have equal variances. These two groups might have unequal variances, right? So remember, when we talk about equal variances, unequal variances, we're looking for the population. It is not that I calculate the variances for those two groups. If they are not equal, I say that, okay, no, they are not equal or they are equal. We are trying to find out the variances, whether those variances will be equal or not in the population, right? So this is where some additional step need to be carried out. I'll show you that, but before that, let's carry out the pair t-test, which is a simpler version, right? Let's say coaching institute, right? MBA preparatory class, some of you might have gone through before you joined MBA. So they randomly selected how many? This is 15 students. So before taking class, right, those 15 students, just 15 students, they used to score 56, 81, 56, 49, like that. They used to score out of 100. After taking class, maybe for 1 month or 2 months, again they have gone through the standardized test, right, and they are scoring like this. The coaching institute is claiming if some student come for their classes, on an average, they will increase the percentile by 5, a percentage by 5, right? This coaching institute claims that students who take coaching in their center perform better. Improvement in score is by 5 points in MBA entrance exams. See, the scores of students in a practice exam before taking class and after taking class is provided below. Carry out appropriate statistical test to prove whether the coaching center's claim is correct or not. Right? Before going into the test, let us try to find out what is our alternate, what is our null hypothesis. What will be our alternate hypothesis? What we are trying to prove here?
Performance is better.
Yes, I think the score is
More than 5.
5.
Okay. So this is, so somebody, the center is claiming, and let's say we are doing that research, right? Our research objective is to whatever data we have, we are trying to prove that for our coaching center, whichever coaching center is that, right? So what they are saying, sir, the difference in marks after taking coaching compared to before coaching is 5 months. Right. Obviously, we are looking into average, right? So there will be obviously variation, that is understood, right? So this 5 marks is on average. So that doesn't mean that every student will be 5 marks higher. Some student will be 2 marks higher. Some student will be 10 marks higher also, right? On an average, 5 marks, right? So the difference in, so some of you want to write in very specific, the difference in average marks scored in entrance. Again, all the details you can write, but simply what it means, what I want to prove is, whatever is my research objective, the difference in marks after taking coaching compared to before coaching is 5 marks, right? So that is what I want to prove. So what will be my null hypothesis?
Equal to less than
Age Exactly. So what I'm telling is, okay, here you have to write is greater than, right? Improvement by 5 marks. So this is again like copy. You can write it as a greater than 5 also, right? Or you can say that not equal to 5 also. Greater than. So let me go through the simpler version. Greater than 5 marks. Here also let me just change that improvement in score is by more than 5 marks. Greater than 5 marks, then
Greater
what will
than
be
equal
my
to 5 mark or only greater than equal to?
alternate hypothesis cannot have equal to sign, right? It always will have either greater than or less than or not equal to. Alternate hypothesis cannot have a equal to sign. After taking coaching compared to before coaching, each either equal to I do not know, less
Less
than
than equal to.
or equal to, right? So rather than writing this big sentence, we can just write it into a simple equation type, right? So this is my alternate hypothesis. Either way, you write the full sentence or you write the it as a formula. Okay. So what I'm saying, if somebody is going through that coaching class, right, average performance in that entrance exam increases by more than 5 marks, right? So that is the average. Always remember, when you talk about average, that doesn't mean that I'm claiming, and that is where some of your placement related queries come. Parents will say that you are telling that average salary package is IMs is 30 lakhs, my son got only 20 lakhs. Why do you are claiming average? So that is the meaning of average, right? Average 30 means some of the students will get 50, some of the students will get also 10. Same thing here. When I say that average performance will improve by 5 months, that is the coaching agency or the organization is claiming. That means obviously some student will score above 10 marks, that performance will improve by 10 marks or 12 or 15 marks. Some student also may not improve, might improve by 1 or 2 marks only. On an average, it will improve by 5 marks. That doesn't mean that for each student it is 5 marks, right? So that is where like people, again, that is other way of false advertisement also. People do not put the star mark. Some people, okay, average means everybody is increasing by 5 marks. But that is a different marketing or advertisement theory. We will not get into that. Our focus is into converting the research objective into alternate and null. What we found out the whatever my research objective, I want to prove that it is greater than 5. Average marks post coaching, average marks pre coaching is greater than 5. That is my alternate hypothesis. Opposite of that becomes my null hypothesis. Clear or any doubt? Anyone having any doubt on this? Either way, you can write in a full sentence or you can write like this. I'm okay with both, but remember the sign where you are putting equal to, where not equal to, all those you need to be careful for. Okay. So now what is my study?
Observed value is greater than expected value.
So that is where I say, when I say object value is greater than expected value, there is no single expected value, right? So I have that expected value I have not given to me, right? Here what I have been given, I have given data of information about group of students. And before going to that, remember that when information is given like that in this format, student performance before taking class, after taking class, read carefully before taking class, after taking class. What does it mean actually? Here I have not written student 1, student 2. Here 56, the same student who scored 56 the same student who is scoring after 81, right? I'll show you why I'm talking about that when I get into the other independent pre-test. So whenever question is asking like this and information is provided like this, right? We are talking about here is the same student. The student who scored 56 later on scored 81. Here the student who scored 77 in the row 23 later on he scored 63, right? The same student, right? So study M here, if you see, I have one group of students. So they are going through some post like coaching. Before coaching, they have given some test. After coaching, they are going through some different test. Now, what I want to find out whether there is a difference in that, right? So if you just go through that PDF document, what kind of studium can be there? Studium can be relationship between two variables. Studium can be or what we did in the last class. Studium can be comparing with your expected value, right? If you have a single variable, you are comparing like ATM usage with 5 or not, right? So that is comparing with a given value or a expected value. So that can be one kind of studium. Studium can be finding relationship. Studium can be finding differences also, right? Here when I say I have a group of students who have gone through before coaching and their study marks, and after coaching I have their marks, right? So to know that after taking the coaching they are performing better, right? What I need to do?
To
So to
test
if I,
whether there is a difference or not before
correct.
coaching and after coaching.
So this is where you have to find your differences, right? You have to understand that okay, why like further why we will not find or why we have to do a qualitative research. We are basically trying to find the differences, right? Whether there is a difference exist or not. Whether it is 5, 10, that is a separate thing. It can be 5, it can be 6, that we'll try to find out. Now the point is we are comparing. We're trying to comparing data point to find difference. Is this part clear? I have two data points. I'm going to compare them, find whether there is a difference. Then that difference might be greater than 5 or not. So this question might be different, right? So whether you are writing greater than 5, that is a different thing. It is better to write. If you are not writing also, it's okay, right? But what is my studium? I have data points. I'm comparing them and trying to find whether there is a difference is there or not, right? In this particular case, it is 5. In some cases, it can be 10. It can be 0 also, right? Studium clear or any doubt? Any questions? Variables. What are my variables?
Average marks.
Average marks.
Average marks. Okay, so that is one variable. So what kind of variable is this? You have nominal, ordinal, ratio, interval. So what kind
Ratio.
of
Ratio.
we can generally will not get into those 4 details. Let me just copy it from here. So as long as we know that whether it is metric or categorical, we should be good enough. So if you go through that PDF document, right? So either interval or ratio, it is a metric data. Nominal or ordinal, it is a categorical data. Marks is a interval data. So average marks is. So why not ratio? We have discussed that before because marks can be in the negative also, right? Marks 0 to 100, 0 to 50, 0 to 20. That is not a universal grading system, right? In USA, same CAT entrance, if you kind of 10 years back, 15 years back, that was a different marking system. It keeps changing. That is not universal. But anyhow, interval ratio for us, it is both the same. Average marks is metric. Do you have any other variable? What other first question is, do I have any other variable? If so, what are the other variables?
Average of before taking class, average of after taking class.
So how many variables?
3.
Okay, Ashish is telling there are 3 variables. Any other answer? Anyone having any other answer?
So I think two variables.
Sir, yes, sir.
What
I
is that?
think two variables.
Sir,
What is the other
before and
variable?
after. Before the class, after the class. Before the class is the independent and after the class is the dependent. So it depends on the classes, sir. I think that.
So you are telling this average marks before taking class, that is one variable, and after taking class, that is another
Yes,
variable.
sir. Yes, sir. Yes, sir.
Okay. Any other answer?
I think only one variable.
So what is that? Average marks.
Yes, sir.
Okay. So remember what we're trying to find out. Like I say, indirectly, where nowhere it is mentioned. Remember what we said in the last. Yes, in the last class we are discussing that, right? Last class in the one sample t test. Your whatever amount of money you spend in education, right? It is written higher education, right? The amount of money students spend in higher education is greater than 361,975. That was our research objective. We went on and carried out a right tail t test, right? But in that particular case, if you remember, though higher education was mentioned, there is no information regarding higher education. I said that yes, if there is certain information in your higher education, then you could have taken that as your variable. Because there is no other information, we said this higher education information we do not have. We have only information on the amount of money students spend on their education, right? And that we took as variable and we carried out one sample t test, right? Only we have one group and we carried out that univariate t test. In this particular case, if you see, I have average marks, so that is varying, right? So that I know. I have also another variable, so that is where the coaching is happening. If you see what I'm interested in, if some students are going through that coaching, are the marks are improving or not, right? Marks is one parameter, marks is one variable which is keep changing. What is the other variable which keeps changing? What is that other variable which keeps changing?
Coaching.
Coaching, because there is an option of pre and post. After before coaching, somebody takes coaching. That is one stage, right? If I take this variable as, so remember variable means what? Variable means which varies. One variable is your marks. Marks is varying. Another variable which is hidden here, which is given in your data point. Remember, like I said, in a higher education, if I had that information, those students who are going through MBA, those students who are going through MCA, then I could have done those kind of tests. That information was not given there. But in this particular case, I know that those same 15 students, they are going through coaching. Before coaching, they have certain tests, certain marks, certain performance. After taking coaching, they have certain performance, right? So this is intelligently hidden in your data point. If this was not given before taking, after taking, this was a list of marks. I was not aware that. So this marks, if I just remove this, let's say I delete this page, I do not know which is before, which is after. I cannot do this kind of two sample data because I do not have the other variable, right? If I just delete this row number 10, which shows before taking class, after taking class, numbers are still there, average marks are still there. That is a variable. But I do not know which is before and which is after. I can put my intuition left side before and right side after. It can be other way around also, right? Somebody might have written after first and before the right side. So this is where your second variable comes into picture, the coaching part which has happened pre-coaching and post-coaching, right? Is this part clear or not?
Yes, sir.
What is my dependent variable?
Average marks.
Average
Average
marks.
marks. What is my independent variable?
Coaching.
So see here, nowhere it is written that average marks is dependent. So if you look into that statement, nowhere is written. But why we are comparing? We believe that by taking that coaching, students are improving their performance or there is no change in performance, whatever may be the case. We're trying to test that. So we are trying to find that whether by taking that coaching, this student, whatever 5 months, 10 months, 6 months, without doing the test will not know, but there is certain change, right? So in our back of our mind, that equation is forming where performance is related to your independent variable, that is your coaching, right? How many groups are there?
Two
Two
groups.
groups.
One
So remember, when we're talking about the groups, the sample part comes two sample or two. If there are three groups here, then the test two sample t test cannot be carried out. So it is very groups is very clear how many data sets you have, right? I have two different groups, two different samples, right? Sample or groups mean same. I have same thing, two groups, pre and post, pre coaching and post coaching. Same thing as your independent variable, right? Whatever the labels,
uh,
yeah.
so in these two groups, like before taking class, after time, they both are the same, na, sir. These are students are both in this case same. So why
Correct.
it's split? Why is it?
But the labels are different, right? Groups of not groups of respondent. So remember what I said. You have groups of data point. So for the same
Okay.
student, you have 56 and 81. So there are
Hmm.
two groups of data point, two groups of not respondent. When that case
Okay.
arises, you will say two groups of respondent. You two groups of marks, two groups of average marks for the same respondent. Okay. So what will be my data analysis method? If you go to that PDF document which I had said earlier, whenever you have comparison, comparison between two groups, we have two sample t-test, right? Comparison between multiple groups more than two, we can carry out another. We are here carrying out differences or comparison between two groups. So we are going with two sample t-tests. So that is for sure. Two groups t-test or two sample t-tests. Sample always remember groups. So I have two groups t-test, but I do not know whether it is paired or whether it is independence, right? So this is where you have to read questions carefully, whether it is given the scores of two different groups of students. If it was asking male, female, or students from different locations, student from online mode, offline mode, right? Here, if you see same group of students, though it is not written here, the same group of students, that is something which you have to understand from the question before taking the coaching class, because otherwise, see what will happen in the problem before taking class, I just take some student who perform very poor, right? No matter what coaching happens. After taking class, I took the marks of only top performer. Coaching classes can do those kind of malpractices irrespective of what they teach. Before taking class, randomly they select the poor performance of the class. After taking class, they take the marks of only best performers and they say that see, marks are improving by 20 marks or 30 marks. To avoid that, same student who is scoring 56 after taking coaching is scoring 81. There are also students who are scoring better, 77. He is scoring 63 now. It is not necessarily that by taking class everybody's performance has improved, right? So this is where for the same group of students you have two sets of different marks, right? So the marks are paired. Why it is paired? For the same group of students, two data points, and both the data points are paired, both the data points are together, right? Is this part clear or any doubt? Why it is not a two sample independent t-test? Because the information is given for the same student. 56, 81 is for a same student, 81, 78 is for the another student. If your student groups were different, male and female, before taking class, after taking class, it was rather than that, it was male or female, or let's say less than 10 lakhs income group, above 10 lakhs income group, or tier 1 cities, tier 2 cities. Offline class, those people who are going through offline classes, those people who are going through online classes. In those cases, you will have a two sample independent test because there will be two different set of students. They are not related to each other. But here what happens? Same group of same 15 students, you have only two data points. For each student, you have two data points. Right? Is this part clear? Anyone having any doubt? Right. So these all the steps need to be there in your answer paper, right? Then once you know that, Excel is going to take care, and you need not, like last class we did some analysis calculation. You need not have to do those things. Once you know that we are two sample, you select the data analysis method and it will be done, right? But this part is important. This part will take some time. So I have anyhow, I'll share the document later on once classes for all the sections are over. But what I'll ask you, go through, like after this class, go through the document, try to question yourself. Just don't believe
Sir,
if I'm saying that, yeah.
Sir, in the variables, you have written that coaching is a variable, sir. But here, all the students which we are taking, all are, of course, taking coaching. So there, it is not
Correct.
varying. Everyone is taking the coaching. Then why it is taken as a variable?
Coaching label is changing, right? When I'm taking the average marks before coaching, that was a one label. So see, variable doesn't mean always it is a continuous variable. Variable can be nominal variable also, male and female. Your pre-breakfast blood sugar level, post-breakfast blood sugar level. When I take that, breakfast becomes a variable because somebody is taking breakfast, somebody before taking breakfast, the blood sugar level is taken care of. Right? Same situation here. Coaching is not a continuous variable. That is true. Coaching, that's why it is written as a nominal or a categorical variable. But it has two labels. Before coaching happened, I have calculated their average marks for each student. Then next label in categorical, we talk about that label of that variable, right? In the next label, what happens? Coaching has happened. That stage which was in the pre-coaching has changed to that varies to the post-coaching. Then again, we have taken the marks, right? So that is where your category, which is coaching, that also is varying. That is not constant.
Okay, sir.
So it is not a continuous variable. Obviously, it is not that how many days. So if it was there, how many days of coaching, 5 days of coaching, 10 days of coaching, 30 days of coaching, that would have been a continuous variable. Here we have a nominal or a categorical variable. Coaching happened before coaching. What was the mark? So coaching has changed after coaching, right? How many days we have not known. Okay. So like I suggested, after this class is over, whenever you have free time till the next class, go through this document, try to logic yourself why whatever I'm telling is correct or not. If you still find difficult, sir told like that, I do not understand, you can still have that discussion. Because if you just remember these steps in the exam, I can guarantee you that you'll find it difficult, right? Because here we are writing two sample paired teachers, there you'll get it confused, right? Whether it is a paired or independent, whether cross tabulation will happen. Most of the times I've seen people who have two sample details, people have put cross tabulation and unnecessary calculation. Okay, anyway, we'll, in case of any doubt, please do ask me. We'll click on the data analysis. We know that paired two sample per means. So go through, click on the data, go through data analysis. I hope this has been covered in earlier classes. If not, just follow my steps. Click on the data, right side data analysis, click on that. So a lot of options will come. Scroll down below, t-test paired two sample per means, click on that OK. Variable one range, ideally what you should take, so what is from where I'm subtracting, right? After taking class, some marks I'm subtracting from that, what is before taking class. When I say that difference is greater than 5, what I mean to say? After taking class, the exam performance has improved. So I'll take my variable one range is after taking class, right? So that is something I hope all of you understand, right? Because that is what I want to prove. After taking class, your marks has improved. Variable one minus variable two. My variable two will be before taking class. So because I'm selecting the label, because I'm selecting this text, click on these labels, right? So what does it mean? Once I select that label, that means the first row of the selected data will be considered as a text data, right? Otherwise it will show error. Hypothesized mean difference. So what is this?
Five.
Yes, because that is what is we want to prove, right? I want to prove the difference in marks from variable 1 to variable 2 is greater than 5, right? So that is what I want to prove. It can be 10, it can be 15, whatever is that is what I want to prove. In this particular case, I want to prove that the variable 1, which is after taking class, post coaching class, performance is better than pre coaching class, which is variable 2 by 5 marks. So that is my hypothesized mean, right? So output range, I'll put it here only. Sorry. Okay. So this part anyhow Excel is doing it for you. So what it says, just if you read properly, after taking class the mean age. So if I take the mean of this 79.13, before taking class is 54. Total 15 observations. See, it is a paired sample t-test. So why it is 15 observations? Because if I see data points is 30, but 15 pair of observations, right? And that is why paired t-test, right? And I have selected a paired t-test. If it was a two sample independent t-test, so there your number of observations would have been 15 into 2. Okay, there are two different groups of people. Here what has happened? Same group of students, right? But I am taking two data points. That's why it is observations is 15, right? Correlation not required. Hypothesized mean difference, that is what I have told 5. T statistics is 2.7. Okay. So there are two ways to do it. If you remember, we did it. I actually did not do any calculation earlier on, but I had told that there is one approach of critical value, another approach of p value. So let us try to go through the critical value first. So my T statistics, that is the test statistics which I calculate, right? That is 2.74. What is my critical one tail? 1.76. Critical total 2.14. Which one I should take? So here if you see there are two critical values.
One tell.
Because I am trying to prove it is a right tail test. If you go here, it is nothing but a right tail test. I am trying to prove it is greater than something. Difference is greater than 5. This is a one tail test. If it was that, just prove that the difference is not equal to 5. It can be greater than 5, it can be less than 5. I am not interested in that. Just prove that it is not equal to 5. Then it would have been a two tail test. Then I could have taken the T critical two tail, right? In this particular case, one tail. Now when I compare, what will happen? What happens to my T statistics?
It is more
T statistics.
critical value.
So if I put that curve, if I put that number line, my critical value is 1.76. My T statistics is greater than T statistics in the right side of one tail, T critical one tail. So then what will happen?
Reject the null hypothesis.
So with 95% confidence,
We cannot access.
we reject null hypothesis. So when I say reject null hypothesis, what does it mean? Alternate hypothesis is accepted. Other way of saying is that yes, the difference in marks, average marks, is greater than 5 marks. So this is what I proved through my hypothesis testing, right? So I started with my hypothesis, I went step on step, then found out my null hypothesis can be rejected, then after taking compared to the before taking is greater than 5 marks. Is this what clear or any questions, any doubt? Then p-value part, right? So this is one approach where you are comparing with critical value, test statistics with comparing with p-value, right? Other way of saying this, remember probability p-value is what? P-value is nothing but if I believe my null hypothesis is true, what is the probability of getting this kind of sample data? If the probability is high, then I cannot reject. If probability is less, I can reject. So what is that high or low? We always comparing with alpha. Here in this particular case, alpha is not given. So take alpha as 5%. If I go by the p-value method, right? What is my p-value? P110. So again, because we are doing a right tail test, we have to take one tail test 0.007. What is my alpha? 0.05 or 5%, right? If my p-value is less than alpha, reject null hypothesis. So here because 0.007 is less than 0.05, why did I get this alpha? Like I mentioned, alpha most of the times we take 5%. So you can here also you can consider as 5%. I'm comparing p-value with a alpha 5% value. Then if it is less than that, it will be rejecting null hypothesis. Then same criteria. Only thing people get confused where I have to take less than, where I have to take greater than. Because here if you see T status is greater than critical value, we are rejecting null hypothesis. P value less than alpha, then only we are rejecting null hypothesis. We are reaching in the same conclusion, but the approach is different. So whichever is like okay with you, right? Both the times, both the cases, I'll show you both, but follow only one method, right? Otherwise, you'll get confused. So this is how with p-value also, by comparing p-value also, we can get the same conclusion. Question, any doubt?
So p-value represents what?
P-value represents the probability of, if I believe null hypothesis to be true, p-value is nothing but the probability of getting that sample data. What is the probability of getting this sample data of whatever, this number? If I believe this null hypothesis is true, if I believe that the average performance will not improve by 5 months, it will be less than or equal to 5 months. What is the probability of getting this before taking class and after taking class, these kind of marks? So that is the p-value. If the probability is very high, what does it mean? My null hypothesis is true, whatever data I am getting, it is aligning with my null hypothesis. If I am getting a very small p-value, what does it say? Probability is very less. That means it is very improbable. So getting this sample data is very improbable. My null hypothesis might be incorrect. Right? Clear or any doubt? P-value I think I had discussed in the two class before. Anyone having any doubt? So go by one approach only. Critical value, if you are comfortable, compare T statistics with critical value. Right tail test, T statistics greater than critical value. Reject null hypothesis. Go ahead by that method. Or if you are going by the p-value compare with your alpha. Anyone having any doubt? Okay. So I'll stop here. We'll discuss the equal variance and unequal variances to sample t-test independence. So today we discuss this part only paired. Next class we'll discuss independent equal variances, unequal variances, and if time permits, we'll at least have the basics of ANOVA, right? Because t-test, okay, no, next class I think cross tabulation. Okay, we'll see what to do. Because t-test will be more like basically related to ANOVA, because whenever you have more than two groups and you are comparing, trying to find differences, basically we try to find out ANOVA, right? Analysis of variances. But what I'll suggest, go through this exercise. Next class, if there is any doubt, still you are not able to find out why it is a total PRT test, or in the calculation you find any difficulty. Calculation you did not do anything, or we did not do anything. The Excel is doing, only thing is that how to interpret this, right? If you find any difficulty in interpretation, right, why we are writing this, right, then still we can discuss in the next class. Okay. So if there are no questions, we'll stop here. And any last questions? Okay, if not, chalo, take care, bye bye.
Recording stop.